the next stuff on the list here, domain and range, comes from the vertical asymptote. So we said that x equals -4 is the vertical asymptote. That's the break point in the graph. Like it's fine left of it, it's fine right of it. It's this break point for the domain. The vertical asymptote leads to the domain, -infinity to -4, union -4 to infinity. Basically, this says everything but -4. Same thing with the horizontal asymptote when it's in this form. The horizontal asymptote is this division, this breakpoint. It's everything up to -3, and then it comes back over this side to -3 like that. So the range here is -infinity to -3, union to -3 to infinity, like that. Any questions on that before we move on to other stuff, maybe new stuff here, x-intercept, y-intercept?
No.
All right, we're actually going to do the y-intercept first. It is the easier of the two. So the y-intercept means to set x equal to 0. So you're literally putting 0 in for x. And if you haven't figured it out yet, like a lot of this is like note card stuff, or if you do Quizlets, like you have to memorize all this stuff. There's no other way around it. It's easy to misremember things. So y-intercept, you're putting 0 in for x. This becomes -1/4 -3. You can use, well, you said you're not allowed to use a calculator. You can make a common denominator here. So it ends up being -13 over 4 like that. It's an ordered pair, 0, -13 over 4. And that's where you might go back to the graph and like put a dot there. Like, all right, that's 0, -13 over 4. To sort of show that you're acknowledging that that is that point, if you want. I don't know what your instructor wants, but. Any questions on that before we go to the x-intercept?
No.
Okay, so the x-intercept is more difficult, more challenging. You're setting the whole thing equal to 0. And unfortunately, it's just more effort, okay? And you're now solving for x. You could maybe try to guess and check for it, but I think it'd be pretty tough. To do that, you're going to add 3 to both sides. So you have 3 equals -1 over x plus 4. You can write 3 as a fraction, 3 over 1. And then typically what students will do here is they'll diagonally multiply. Hopefully this all looks familiar
Yeah.
to you. And then 3 times x plus 4 equals -1. 1 times negative is 1. You could distribute in, you could divide. I guess we should distribute in. 3x plus 12 equals -1. Subtract 12, and 3x equals -13. Divide by 3. X equals -13 over 3. So the x-intercept, again, it is an ordered pair. Y is 0, but x is -13 over 3. So you might want to go and put that again in your graph. Like that. If a student did this for me, I'd be pretty excited that they had done everything. Like that would be, I don't really care that's not accurate in terms of the shape. Like they got all the useful information. There's a reason there's a sketch artist, like this is not artistic. You just label the important information.
Okay.
All right, now what we have not done is this end behavior stuff,
Yeah.
which really does come from the graph. So, I'm going to just briefly sketch this graph again. We'll hopefully be able to, so it looks like this and like this. Okay. So oh gosh, your instructor is doing it this way. Um, All right, so I'm trying to decode this. So this first part is referring to the vertical asymptotes. And it's very awkwardly written. The answer, let me just give you the answer here so you can, and then we'll work backwards. Like why is it the answer? So as x approaches -4, so this line right here, this vertical line right here is -4. As x approaches -4, as x approaches -4, do you see how the graph goes up and the graph goes down?
Yes.
That's what they're referring to, plus and minus infinity. They're saying that one goes up, one goes down. This notation is incorrect, but that is what your instructor has given you. You really are supposed to separate it from the left and from the right, but they do not do that. But the first thing here is vertical asymptote. The end behavior, again, this is really awkward. You actually want to read it like this part first. The x goes to minus infinity. You really want to read that first. So that means to the left. That means as you traverse the curve to the left forever and ever and ever. And it approaches, what does it approach? Well, it approaches this y value. This y value is -3 on both sides. So you can see as you approach the curve to the left, it approaches this y value of -3. As x approaches infinity, this is again, you really want to read this part first. This is to the right, meaning like imagine you're traversing the curve to the right forever and ever and ever and ever and ever. What does it approach? It approaches that value of -3. These are often the same value. Often. Math is full of exceptions.
Okay.
All right, where should we go from here?
Let's see. Which one? I know we started a word problem kind of looking one. I can't find my paper.
Yeah, we did 7. Remember Cheney County. Do you want us to do it again? Do you
So
want to
there was
move
one
on?
there was one like that on my quiz and I was able to do it, but the ones under those ones, the slope intercept form ones, there's one of those and that's what I forgot how to do.
All right, let's take a look at those next. Yeah, it's good that you're recognizing. You're like, okay, the one I got additional help with, I knew. These I didn't. I mean, that's a good point of reference for future quizzes and tests. So, all right. There's a lot here. It says, write the equation of a line that is parallel to, and passes through the point. Okay. And it should say in slope intercept form, like it should actually be written in that order, right? The equation of line is parallel to 2x minus y equals 8 and passes through the point 2, -5 in slope intercept form. Okay, so 2x minus y equals 8. What is the slope? And this is a question for you, and your answer should be something like, I'm not sure. And the reason you would not be sure is because it's not in a form that you know how to find the slope of. So if you could get it into this form, basically solving for y, you could get the slope. Could you solve this for y for us, please? Tell me what you come up with.
I don't know.
Okay,
Let's see.
so to solve for y here, we're looking at the side with y, and we're going to undo the 2x. Is the 2x being added or subtracted?
Subtracted. See if that add it.
The y is being subtracted. The 2x actually has a plus in front, but it's not written. So you undo it by subtracting. Now, it's best to put that in front of the 8. And this negative goes with the y. So it's really negative y equals minus 2x plus 8. Take a look at that, get that down. You know, if there's something's unclear about that or you don't like it, let me know. We'll try to resolve it now.
Okay.
Okay, now y is not by itself because it's not just a y, there's this negative in front. How do you undo a negative?
Um,
Do you remember that?
no.
So there's two options. You can multiply or divide. I always divide. It's always been my preference. You divide everything by -1. So that's y equals 2x minus 8. And now it's in this form, which is good because you can then tell me the slope. The slope, m, is the number in front
So 2.
of x, 2. Now this is where this is a mixed problem where you've got a lot of things going on. Parallel means same slope. Parallel lines have the same slope. You know, streets that go in the same direction have the same slope. So the slope of your new equation is 2, and it passes through the point 2 comma -5. All right. So you are completely done with that old equation. You want nothing to do with it. You've broken up with it. It's over. And now you're looking at slope and a point, but it has to be in slope intercept form. So you have to know, well, what is slope intercept form? And it is y equals mx plus b. The reason it's called slope intercept form is because it has a slope m and an intercept b, y-intercept b. The name tells you what it is. It's like when you go to In-N-Out Burger, you know what you're getting. You're gonna be in and out, you're gonna get a burger, except there's usually a line.
Yeah.
Right? I mean, yeah. All right, so now you put this number in for m. Y equals 2x plus b. That's the first thing, all right? To solve for b, you use the point. Your point is an x and a y value. So you have -5 equals 2 times 2 plus b. Okay, so notice that when you put the x and the y in, the only thing that's left is the b. We're going to simplify this equation. 2 times 2 is 4. -5 equals 4 plus b. To solve for b, you subtract 4 from both sides.
So B
b
goes.
equals, and that goes back into this line here. Your final answer is 2x minus 9.
Okay. For the one under it, what is so if parallel is the slopes the same, what is perpendicular?
So good question. That leads us right into number 9. Um, and again, it should say in slope intercept form. Okay, so we're going to take a look at this right here. 3x plus 4y equals 12. This is already in what's called standard form. We really want to put it into y equals mx plus b form because that will tell you the slope. So to do that, you have to solve this thing for y. Again, just like the previous problem here, you're going to subtract 3x from both sides. And I like putting that in front there. So it's minus 3x plus 12. You really don't want to put it off to the side here. It'll be confusing long term. The best habits, really come from just doing the right stuff from the beginning. So now there's not a negative in front of y this time. There's a 4. So you undo multiplication by 4 is dividing by 4. Y equals negative 3/4 x plus 3. All right, so what is the slope of this one?
-3/4.
Good. Okay, now we're done with that equation. Like it's gone. Don't care about it anymore. Now, perpendicular slope. There's a rule here, and there's two ways students remember it. It's flip, negate, or you can think of it as opposite, reciprocal. They're both fine. If you have another way, that's fine. You flip the number, but then you negate it. And so if you have two negatives, that makes a positive. So one of the slopes is negative, the other will be positive. So this is the perpendicular slope here. This little, I don't know what to call it, like a tree base thing. It's perpendicular is what it means. Okay, so just like the previous problem, you now have the slope. And it goes through the point -2, -5 like that. So we're basically like done with everything from the previous part of the problem. You just have to now write the equation of the line y = mx plus b. The 4/3 goes in for m, so it's y = 4/3 x plus b. And then you've got an x and a y again. Your teacher didn't choose nice numbers, unfortunately. But nothing we can do about that. -5 = 4/3 times -2 plus b. If you don't recall how to manipulate a fraction by multiplying, you multiply the top and then you multiply the bottoms. Any number can be written as a fraction like that. So this becomes -5 = -8/3 plus b, and then you add it to the other side of the equation there. So you have -5/1 plus 8/3 equals b. You really want a common denominator here between these. So make it 3. And then when you're adding fractions, you add the tops and keep the bottoms. You end up getting -7/3 equals b. And that goes back into all the way back there. So it ends up being y = 4/3 x minus 7/3. It's really, really common for these to have the same fraction, same bottom there. All right, do you want us to do 10 as well?
Yeah.
Okay. We should also do like version 10b, where we do the other type of problem that you might see here. So it says write the equation line that's perpendicular to x = 5 and passes through this point here. So first thing is you have to know that x = a number is a vertical line. You just have to know that. There's no other way to do this problem. And then y = a number is a horizontal line. So if we go to the graph here and we do this fairly accurately, this is x = 5. And if you're wondering how to remember this, one thing that I found is really useful is I actually think of it this way as x is always 5. So what do I mean by that? Well, if I pick like this point right here, x is 5 and y is 1. And if I pick this point here, x is 5 and y is 3. what is x? Well, x is always 5. Okay, so that's how I remember that. So a vertical and a horizontal line are always perpendicular. Okay, so the answer to this problem is y equals something. Okay, now if we graph this ordered pair, -3, -2, there's that point right there, and I draw a horizontal line through it. And then let me just graph another point on here, -3, 3. What is y always on this line? Sorry, I graphed, like, this is completely wrong, sorry. All right, what is y always on this line? What is the y value always in this case?
-2.
-2. So you actually don't even need to graph this, just helps. You have to know though that vertical lines, horizontal lines are always perpendicular, and that the point actually tells you what it is, like what it's going through there. So there's a analogous problem to this, like, which is where it says write the equation line is perpendicular to y equals 5 and passes through the point -3 comma -2. So y equals 5. 1, 2, 3, 4, 5. It looks like this. This is the line y equals 5. Because you get one or the other on a test. -3, -2. So there's the perpendicular line. And the answer is x equals -3. X is always -3 on that line. So just something to think about there. Okay. What else could we look at today to help you out?
Um, the one that she sent you today, that's Thursday or whatever, I believe, or it says Thursday next to it.
Yeah. Now, in some ways, this what we have here is actually easier than what we've been doing. We'll take a look at this here. All right. Write the equation of piecewise graph. How many pieces do you see?
3.
Good, 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 good. Okay. So sometimes that's the easiest thing to do is to figure out the divisions here and to actually do that first. So f of x equals big curly braces. You've got piece 1, piece 2, and piece 3. To the right here is where you indicate the inequality. And if you're not sure what I mean by that, the first one is valid from all the numbers less than -3. Does it include -3 with the open circle?
Yes.
So closed circles include, open circles exclude.
Is that is it the one that like has the line under?
Yeah. So so
Oh,
when you see this symbol, it could be this one or this one. This symbol is this one or this one. Okay. So the reason that's important here is this first one is valid from x less than -3. The one on the right, the last piece here, is valid from, I got this kind of, so that, see, it's an open circle there, x greater than 2. And then the one in the middle is good from -3 less than or equal to x less than or equal to 2. All right. Now the next thing is to figure out like what is each of these. And sometimes it's good to like put a word here, like this is a line, this is a line. It's actually a horizontal line, which is helpful because we just did those. And then the one in the middle here is a parabola or a quadrat. Sometimes it's good to do that. Let's do the easy ones first. The horizontal line. Do you remember this from the previous problem? What is the equation of a horizontal line?
Um,
And scroll up if needed.
yeah.
All right, so horizontal lines are always of the form y equals a number.
So
What
y
is the, yeah, what is the y value on this line here?
6.
6. So you don't write y equals 6 though, because you already have an x, like the f of x is the y. So it's just the 6, like y here equals 6. Now let's go do the other line. So we just did a bunch of those. It's y equals mx plus b. Do you remember how to find the slope from the graph?
Um, I don't.
Okay. So graphically, you pick a nice place on there, and it's always rise over run. So the slope in this problem is the rise over the run. The rise could be down though. In this case, it does go down, goes down 1. The run is always to the right,
The 1/1.
-1/1, because it goes down. Since it goes down, that's why it's
Negative.
negative. Okay. To find the b value, because you have the graph, you can basically just extend the line and be like, where does it hit? And it hits right there at -2. That's a shortcut. There is another way to do it that's more mathematically correct, but you can just extend the line. So your slope is -1 and your b is -2. Since you already have the y over here, you put in the -1x minus 2 there. Any questions on that?
No.
Okay, for the middle one here, that's the most difficult. That's the quadratic. You have to know the quadratic parent function, which is y equals x squared. But the graph of y equals x squared starts here at the origin. How would you describe what has happened from the parent graph to this one here?
It goes down 4.
Goes down 4, yeah. So down 4 would be like that, -4. There could be more, but they typically don't do a lot of transformations of these because they're hard to figure out. You actually have to look for the fact that like up 1 over 1 and then up the 4 over 2. There's a way to kind of make sure that it's truly the parent function, and it is in this case. So that is the middle one there. So to summarize, the way to do these is you break them up like we just did into the pieces. You do the inequality stuff first. That's just as valuable as this other stuff. And then write what you think it is, and then try to remember the equations of each for this,
For each line or whatever.
or whatever it is. Yeah. And that's the only. Now, the last part here to find f of -3, we actually don't need the piecewise function to do that. We can actually do it right from the graph. So let me do that here real quick for you. So to find f of -3, that means that x is -3. So you go, okay, there's x is -3. So it's either there or there. Which one is the filled in one? Well, it's the top. So what is the y value there?
5.
5, that's it. You don't need all these lines, but that's the progression in terms of your, your thinking through it. I'm gonna just step away for 30 seconds while you figure out what you want us to do next. I'm just gonna grab some water. I'll be right back.
Okay.
All right, where do you want us to go from here?
Um, do you have like the one that we just did? Is there a way to do one like similar? I don't have another like
Oh yeah,
one.
yeah, no. That's one of the benefits of working with me is I can absolutely get uh other problems here. And the best part is really for you to try to work on some of these on your own here. So let me uh let me find a couple here and see if usually you start out with just two graphs. These don't have the graphs. We want to go backwards from the graph. So give me. Okay, here we go. This is a good one. All right, so what I'm going to do here is give you the graph and trying to make this as large as possible so you can see that there. There it is. And so you want to be able to come up with the function. There are two pieces this time. I recommend first coming up with the inequality for each of them, and it's always from left to right, top to bottom, but it's really left to right. We read left to right, that's just the way we do things. So it's consistent. So if you want to give this a try, do you have questions? Let me know.
Okay. For the top one, I did negative 1x minus 1, comma, x is less than 2.
Okay.
And then the bottom one, 1x minus 4, and x is greater than or equal to 2.
Okay, so we're just having an issue here with, oh, I'm sorry, let me take that back. We're having an issue with slope on these. So this part is kind of okay. It's actually less than or equal to because of the filled in dot there. And then this one should be a greater than 2. Maybe I misheard that, but that's okay. Now on the slope front here, this time it's down 2, right 1. So down 2, right 1. So the slope there would be -2/1.
So it'd be negative 2 in front instead.
Yes. Okay. Now the one on the right here uh, is down 1, right 1. So the second one slope is -1/1. So it ends up being -1. Now the intercept though, it is 4, but it's positive. +4 there like that.
So plus 4. Okay, yeah.
Yes. Okay, let's try another one. You're close. It's this, just I'm sure it's just the fact there's a lot of steps here. That's probably not helping a ton. This one for a reason didn't print a line there like that. These all go by 1, by the way.
Okay.
So give this one again a try.
On the first one, I'm stuck on the slope of it, or
Yeah, so this time it goes up 1 and right 1. So when it goes up, that's positive slope. When it goes down, it's negative slope. Does that help?
yeah. So would it be 1x plus, hold on. 1x plus 1. 5.
Okay. And give me the inequality for that here.
X is less than, um,
What's the X value here?
2
Nope, 2 is over here.
or -2.
Yeah, it's a big difference, like being on the wrong side of the street. It could be really bad. Okay, do you have the other one or do you need some more time?
I have -2 and x is greater than or equal to 2.
So that would be if, again, if it was 2, it'd be over here.
-2.
Yes, it's really important. It's like difference between having your shirt, inside out or outside, whatever, outside. It's like, the huge difference. So, all right, really good, really good. We got time. Try to do one more here, if we can. Um, yeah, let's try one more here. See how much we can get done. You have a tight schedule today, so just do your best here. This one's got 3 pieces. Consider. All right, just because we are running out of time here, I'm going to throw in the solution here in case you want to look at this later. All right, so the first one here is 1x plus 2.
Okay.
Next one is 1x plus 3. And the last one is 1x plus 1, like that. All right, so we do unfortunately have to stop here. Got kind of a tight schedule, but